When you reach out and press your hand against a desk, it pushes back. It feels dense, permanent, and entirely independent of you. We base our daily lives on this intuitive assumption that the universe is a stage filled with solid objects moving through a fixed flow of time. But as we pull focus and look closely at the fabric of nature, that comforting certainty dissolves. Our senses report a world of objective persistence that laboratory evidence fails to find. Two radically different traditions arrived at this convergent conclusion. 20th century quantum physics reached it through mathematical rigor. The Vedic seers named it 3,000 years ago as the concept of Māyā. Curious, if the solid world our senses report is actually a constructed veil, what exists behind the appearance? The answer lies in the nature of interaction. Both traditions suggest that reality isn't a collection of isolated things, but a continuous process of relationships that brings the world into being. For centuries, the Newtonian cosmos provided a neat clockwork universe. Particles moved like billiard balls across an unchanging stage. Modern physics dismantled that stage. This diagram shows the double-slit experiment, where a stream of photons passes through two narrow openings. Without interference, they produce a shimmering wave pattern on the backscreen. But the moment we use a device to detect the path each photon takes, the wave vanishes. The light hits the screen in two distinct clusters, behaving like solid particles. Zooming in on the detector, we see the mechanism of change. It isn't a human mind that alters the result. It is the physical exchange of information. When the detector interacts with the photon, that data radiates outward into the environment, forcing the system to choose a single state. This process is called decoherence. In our everyday world, quantum systems are constantly bumping into air molecules and photons, leaking information into their surroundings. From this ceaseless interaction, the classical, solid world we recognize emerges. These 2 points of light represent quantum entanglement. When particles interact under specific conditions, they become bound in a shared state. Even across a vast void, a measurement of one influences the behavior of the other. At this depth, the boundary between separate objects is incomplete. Physics describes a universe of interconnected relationships. The solid world is a surface appearance, generated by nature perpetually observing and interacting with itself. This pattern of constructing reality finds a striking parallel at the scale of human biology. Recent models of the brain suggest that our internal experience follows a similar architecture of construction. The predictive processing model developed by Carl Friston describes the brain not as a passive camera, but as a prediction machine. It continuously generates models of the world and compares them against incoming data. This diagram illustrates the process. Our sensory organs receive a fragmented stream of ambiguous data points. The brain instantly processes this against internal templates, then renders the result into the recognizable shapes, colors, and textures of our experienced reality. We see the consequences of this construction in the biology of attachment. When a stimulus hijacks the dopamine system, our attention narrows. The brain fixates on the object of desire, systematically filtering out the broader situational context. Human perception is an active, flexible construction. Because we live within a representation generated by our own biological hardware, the veil is a feature of the mind itself. Ancient Vedic philosophy calls this internal construction Māyā. Rather than dismissing the world as a hallucination, the texts define Māyā as the sacred art of fascination, the divine ability to distract through enchantment. The myth of the cosmic churning provides the map for this idea. The Devtas and Asuras, the demigods and demons, worked together to churn the ocean of milk, hoping to extract the Amrita, the nectar of immortality. Once the nectar emerged, the Asuras broke their alliance. Driven by a compulsion to seize everything for themselves, they took the vessel and fled. In this motion, we see the Mohini avatar emerge, the divine wearing the form of enchantment. She appeared with such unhurried grace that the very air seemed to slow around her, her presence designed to answer the precise longing of those looking. The Asuras behaved like a hijacked neural circuit. Mesmerized by the presence before them, they forgot their strategy and their victory. Their attention narrowed until they willingly surrendered the nectar to her. While the asuras were captured by the appearance, the devtas maintained their awareness. They faced the same enchantment but remained aligned with their purpose, allowing them to receive the true nectar. The Mohini avatar encodes the core lesson of Māyā. The danger of illusion lies in the quality of our interaction with it, whether we are locked in rigid attachment or anchored in flexible awareness. These three pillars converge on a single insight. Quantum models point to a relational cosmos. Neuroscience reveals a brain that constructs its own world, and ancient myth provides a map to navigate the result. The Vedic tradition treats this veil of appearances as a luminous classroom. It is a space designed to instruct us through the very mechanism of fascination. Sacred discernment offers a way to engage with this classroom. We can learn to redirect our attention without needing to aggressively suppress the ego or enter a battle with our desires. This starts with the simple act of naming. When a compulsion arises, speaking the desire plainly, "I want this," brings the craving into the light of awareness. Naming the enchantment reduces its unconscious power over us. The world of appearances is designed to captivate us, but by seeing clearly what enchants us, we gain the freedom to choose our response. Awareness turns the distraction into a guide toward the truth behind the veil.